Hi, and welcome back to Not Quite Dead Hi-Fi. In this episode, we're going to take this Micro Seiki DQ-3 turntable and try and keep it out of the grave. I found this turntable on Facebook Marketplace and paid just $80 for it. The DQ-3 is somewhat of a rare Micro Seiki turntable made just for a couple years up in the late 70s. It was sold primarily into the Japanese and European markets, so it's kind of weird that we found one in North America, especially where I live on the Oregon coast. Like many examples of the DQ-3, this one did not have its original Micro Seiki MA707 tone arm. The MA707 is a highly sought after, highly desirable tone arm, very high performance. I'm guessing at some point the seller took it off and sold it, meaning we're thinking that it was easier to ship a tone arm than a whole turntable. In the shop, I happen to have an MA707 clone of sorts, an ADC ALT-1 tone arm. Both are typical straight tone arms that are about 11 inches long. The ALT-1 certainly is no match performance-wise for the renowned MA707, but I've used it for several turntable builds. It's a reliable and very decent performer. With the resurgence in all things vinyl, it's getting very difficult to find inexpensive, high-performance turntables and especially tone arms. A trick I use is to look for complete turntables that have the item that I want, in this case a tone arm, and specifically the ALT-1 tone arm. It was fitted to several turntables branded under the ADC name, and of which the DD-1600 is the most commonly available. You can buy a DD-1600 on eBay for under $100 all day long, especially as you don't care if the DD-1600 works. What you want is that gorgeous ALT-1 tone arm to repurpose for another project. I couldn't find any service-related documentation for the DQ-3 online. I usually recommend downloading service and owner's manuals before you get started on a project. But the DQ-3 is a pretty basic turntable, so if we uncover any problems, it should be pretty easy to fix. Most commonly, you'll have to replace the electrolytic capacitors. Looking at the product label on the back, it would appear this DQ-3 was built for the Japanese market since it's designed to run off 100 volts. In North America, our voltage is closer to 120. Most products designed to run on 100 volts will run on 120 okay, but later on in this episode, we'll do a quick check to make sure that everything will be fine. Without the tone arm, there's very little we can do to test the DQ-3, really just a speed check. So we're going to put this strobe disc on. Unusually for the DQ-3, it doesn't have any way to adjust the speed or measure the speed. Most direct dive turntables had a speed knob and a strobe pattern screened onto the platter. The DQ-3 for some reason doesn't have that. So I printed this out from a website, vinylengine.com. You can go and do the same thing. We'll put this onto the turntable and then fire it up and check the speed. Since it doesn't have a strobe in it, a little project I built years ago is a little handheld strobe light designed, you can use it to test the speed of turntables out in the field before you buy them, that kind of thing. I'll post information on this little item. You can build one yourself, or if I feel adventurous, I'll try to make kits available online, people that want to make one. So we'll fire the turntable up and see what the speed is like. So checking it at 33 1/3, the speed seems bang on. We'll switch to 45, and checking it at 45, the speed's perfect as well. So we don't really have to do anything to repair the DQ-3 other than install the tone arm. I pulled the ALT-1 tone arm off its DD-1600 donor turntable many months ago, so unfortunately I won't be able to show you that process. But it's really not that difficult. Just be very careful, very methodical about taking the screws out, lots of photographs so you know where things go, where things came from. Just a lot of caution and care. Tone arms are fragile things with bearings and whatnot, but it's really a pretty simple process. The same with installing the tone arm. It may seem like a difficult task, but it's really not that hard to do. If you're lucky enough to find a tone arm new in the box, it'll come with the installation instructions as well as an alignment jig that'll help you locate where the pivot point should be on the base of the turntable. In the case of the ALT-1, I was able to download the manual, but obviously you can't download an alignment jig, so I just made one out of a piece of paper. You can see it here. With a straight tone arm like this, the distance between the center point of the spindle and the pivot on the tone arm should be 22 centimeters. So you can just take a piece of paper, mark the spindle point, punch a hole through, and then use a ruler to draw a mark precisely 22 centimeters away. Then you can just put this over the spindle and use it to locate that mounting point for the tone arm. The geometry used in turntables is pretty straightforward. They've been making these things for a long time. They've worked out all the kinks. And as I mentioned previously, the center point, the pivot point of the tone arm should be exactly 22 centimeters from the spindle, center of the spindle. Since our ALT-1 is so similar to the MA707, I'm pretty confident it's going to work out just fine for this project. Now in the case of the DQ-3, we already had a hole drilled through the motorboard where the MA707 was. And conveniently, it happens to be exactly 22 centimeters to the center point as we need. If your turntable doesn't have a hole drilled through, simply take the piece of paper like I showed before, and make this little jig. You'd mount that over, draw an arc on the motorboard at 22 centimeters, and then using the tone arm, find a location where you can drill a hole through where the tone arm won't interfere with the dust cover or any of the controls on the turntable. I like to use a Forstner bit to drill holes through motorboards. They drill through with far less chipping, make a nice clean hole. On something like this, you want to keep the installation as clean as possible. You don't want to damage too much if you can help it. So just carefully mark your center point, center punch, and then drill a hole through the motorboard, and you'll be ready for the next step. So we're at that point where we're going to mount the tone arm. When mounting the tone arm, recommendation for me would be to follow any instructions that you have for your particular tone arm. In the case of the ALT-1, depending where if you want to follow the same process we're doing, depends where you get it. There were 3 styles of mounting that the ALT-1 arm had. The first one was kind of shown on the picture here, was a threaded sleeve. Basically a large nut would bolt the arm to the motorboard from underneath. The second way that the arm was provided was something called a slide mount. It's a bracket that you would bolt to the motorboard, and then the tone arm attaches to the bracket. The benefit of this, if you can find one, is you can adjust the arm back and forth to precisely hit that 22 centimeter number. The third method, and this would be what happens if you pull a tone arm out of a DD-1600 like we did, is you have to use the same screw holes that were used to mount the tone arm on the DD-1600, which is going to mean that you have to drill very carefully through the base plate of the tone arm to open up those holes. You can see 4 screws here where I've had to do that. Again, it's not difficult if you have to follow that method. Just be very careful, very slow. Make sure you support the tone arm. I like to use a couple of wooden blocks to sit the base on so that it's easy to get around. And then when you drill through, there's nothing underneath that the drill is going to catch into and maybe spin the tone arm on. So now we've got the tone arm mounted. The next step is going to be mounting a plate on the back of the motorboard to attach the wires from the tone arm coming from the cartridge to. You're going to have to make this, and it's highly unlikely that the motor base, will have any holes you can use carry over from before. In the case of the DQ-3, there were no jack holes, nothing on the back where that original MA707 was connected. So we had to make a little plastic plate. I recommend using plastic so you keep the grounds for the left and right channels separate. A metal plate would short those together and possibly cause hum. Now the tone arm manual will indicate what each color wire does where it comes out of the bottom of the tone arm. In the case of the ALT-1, I made a little cheat sheet here kind of showing what the various wires do, and you can see the underside of the turntable where these wires connect up. You'll also have to provide a connection for the ground wire. I like to use binding posts for this purpose since they can accept a variety of connections, a piece of wire, a spade lug, or even a banana jack if you want to. I also like to keep the audio ground and the electrical ground for the turntable separate. It gives you some options later on. If you do have some hum in the signal, you can either join the grounds, split them apart. Gives you some things to play with to try and fix the hum. So we have the bottom off the turntable, and you can see this board here is the power supply board. Obviously, this was designed to run on 100 volts. We're going to run it on 120. That's about 20% higher, which means the voltage coming out of the power supply is going to be 20% higher. So what we want to do is make sure that voltage doesn't exceed the rating of this main filter capacitor, this blue capacitor here. We also have to be concerned that with that higher voltage coming out, this regulator transistor you can see mounted on this heatsink can handle that extra few watts of power dissipation. So We're gonna hook up the test meter and I'll be right back. So we have our test meter hooked up. I checked the capacitor and it has a rating of 50 volts DC. So we need to make sure that with our extra line voltage, that the measured voltage across this capacitor is less than 50. So we're gonna turn the turntable on and the voltage reads 36 volts. So we're well within specification for that capacitor. No need to replace it with something with a higher rating. The last thing is the power dissipation. So that regulator transistor was on a really big piece of metal underneath. I'm looking at the plate on the back here. It shows the whole turntable only consumes 5 watts. So with 20% higher voltage coming out of the power supply, that really means that the whole turntable will now consume 6 watts. Not a significant difference, so we don't have to worry about anything getting too hot. So now we've got our tone arm installed, we've got our wiring all hooked up to the back of the turntable, our ground connections are ready to go. We're just about ready to start spinning some vinyl. All we have to do now is a few checks on the alignment of the tone arm. Now, if we got that pivot point exactly 22 centimeters, then the tracking error should be very close to the tone arm specification. If we missed by a little bit, then we'll have a little bit more tracking error. So tracking error is a result that we have a fixed pivot point and the arm has to move across the record. So in an ideal perfect world, there would only be one point across the surface of the record where the cartridge is exactly parallel to the grooves. The rest of the time, there would be an offset angle or tracking error that needs to be corrected. So one of the ways turntable manufacturers years ago got around this problem is, rather than having one point where the error is 0, we twist the head shell slightly and we create 3 points across the surface where the tracking error isn't 0, but it's very, very low. To avoid all the mental craziness that goes through trying to do all the geometry, it's easier to just go download one of these cartridge tracking error alignment gauges. You can get these from the same website, vinylengine.com, where you got the strobe disc. Basically what you're going to do is sit this over top of the spindle, push it down on there, and then pick your tone arm up. Be careful if you got the cartridge installed to flip the little guard down to protect the stylus. And you're going to center this over top of this little graph that's printed on here. Then you're going to sight down from above and make sure that the cartridge body is exactly parallel to the markings on the template that you printed out. And you're going to check this at the inside area and then rotate things around and check it at the outside area. And in the case of our turntable, because we had that hole already drilled and it was the right distance, the tracking error, what I'm seeing is it's exactly parallel. I don't see any reason we have to move the cartridge. If you did need to adjust it, there's a couple of screws that hold the cartridge in. You just loosen those off and then very, very carefully wiggle the cartridge till it's parallel at the first point, and then move it over, check it at the next point, wiggle it a bit of trial and error back and forth. Eventually you'll get it to where the tracking error is very, very low at both points, and you're finished off with that adjustment. So now we've got the tone arm mounted, the connections made, we've checked the tracking error. The next step is going to be something called cartridge overhang. Basically, this is a distance that the stylus is going to sit from some reference point on the head shell. Depending on the tone arm, this can be really easy or ridiculously complicated. And in the case of the ALT-1 arm, it's ridiculously complicated. Basically, what they want you to do is set the distance from the tip of the stylus to the front edge of the head shell here at 3.5 millimeters. That's just not possible to do by eye trying to hold a ruler up. So a far easier way to do this is to use the alignment protractor that we just used to set the tracking angle or check the tracking angle. Basically what you're going to want to do when you're checking the angle is make sure that the stylus tip sits exactly on that little X in the center. And you might have to slide the cartridge back and forth a little bit to get it to be precise, but that's far easier with the ALT-1 than trying to make that measurement. Now, some tone arms, it's much easier. Like if you had an SME tone arm, they measure this distance from the back edge of the head shell, so it ends up being something like 10 or 15 millimeters. That's something you can actually measure with a ruler by eye and have a reasonable chance of getting it close. Getting almost done with all of our checks and adjustments. So one of the last things we have to do is check and or adjust for something called the vertical tracking angle. So this is the angle the stylus makes where it contacts the record. Now in a perfect world, that angle would be the same as the master disc cutter was at the factory where the master disc was made. Typically, that angle is between 15 and 20 degrees. Records back from the maybe mid to late 60s, even early 70s, would have used a 15-degree angle. More modern records were cut at 20 degrees. That should tell you right away that vertical tracking angle doesn't have to be set precisely. We just want to make sure that it's not like crazy wrong. So when you're mounting a tone arm, the easiest way to know if you've got it close is if the tone arm is parallel to the record platter. And you should try when you're mounting your tone arm to get that tone arm as parallel as possible. It will make setting this angle so much easier. In the case of the ALT-1, there are two little screws on the back here that let you raise and lower the tone arm on the mount. So in this case, you would mount your tone arm, loosen the screws, move it up and down as necessary to get it parallel. With the DQ-3, we've got the mounting for the arm as low as it will go. And if you kind of sight across it in the video here, you can see that the arm is almost parallel. If anything, it slightly tips forward. I've measured the tracking or the vertical tracking angle and it's around 18 degrees, so it's not bad. But to do that, I'm going to reach over here out of frame for a second. What I did was I used another turntable mat to lift the record up, and that compensated for the fact that the arm wasn't perfectly level. So we just put this second mat over the top. The record sits 1/8 of an inch higher, and we can adjust that vertical tracking angle without having to mess with the tone arm too much. Again, keep in mind, vertical tracking angle, don't get carried away with it. Years ago, it used to be a big topic of discussion with the audio nuts. It's really not that critical as long as it's somewhere between 15 and 20 degrees. And really that means if you have your tone arm more or less level with the platter, it's going to be in that range. You'll be just fine. So I know I just said don't get too wound up on vertical tracking angle, but if you really want to double check and be sure, there's another way you can look at the tracking angle to see how close you are. And it's something called stylus rake angle. So this is the same idea. Rather than measuring the angle between the stylus and the tone arm, which is that vertical tracking angle, what we're instead going to try to measure is the angle of the stylus to the record. This is known as the rake angle. Typically, it's going to be in the range of 3, 5, maybe 7 degrees. The specification will be typically provided by the cartridge manufacturer. In this case, we're using a Denon DL-160, and they suggest the rake angle be somewhere between 5 and 10 degrees. Again, basically you just do this by eye. If you have an old high school protractor, you can kind of hold it up in front of your eye as you're looking over and get some idea of the angle. That'll tell you if you've got close. So there's kind of two ways you can use to check vertical tracking angle, either by measuring that first angle or the rake angle as an optional way to do it. How do you know if you've got it close or if it's wrong? Again, simplest way I've ever found is to listen to the quiet sections between tracks on a record. If the vertical tracking angle is really, really wrong, you'll hear lots of crackles, surface noise, because the stylus won't be tracking the groove on the record at the correct angle, and you'll hear sort of scraping sounds. If you've got the vertical tracking angle close, then that between record sound will generally be very quiet. You won't hear much of anything, just some ticks and pops typical of playing back a record. Again, like I said previously, don't get obsessed with vertical tracking angle, but since you're mounting your own tone arm, you actually have the luxury of being able to adjust it and check for it. If you were to buy a factory-made turntable with a tone arm already installed, you'd be stuck with whatever the manufacturer provided. So it's nice to have a way to check and adjust it if you want to. All right, so we've gone through all of our tone arm adjustments, except for one. And I should say here, even if you bought a record player, online that comes with its own tone arm ready to go, some of these adjustments you can check if you want to. You might not be able to do so much adjustment, but it might be worth knowing. So this last one is balancing the tone arm. This would be a critical adjustment on any turntable, even when you buy that's all factory ready to go. And the basic idea is first off, I would recommend if your cartridge has a little protector, I can show you on this one here real quick. You can flip this little protector down just like that. It protects the stylus from damage. What we're going to do is move the tone arm over onto the platter, and you can see it's sitting down. We're going to turn the counterweight on the back, backwards slowly, keep going back, until eventually you can see the arm begins to float. And we want to get it, adjust it, so that the tone arm you can see how it's floating back and forth. Still a little bit more. So there we go. The tone arm is kind of floating here. If I touch it, you can see it just goes back and forth. So now we've got that set. We move this little scale on the back until it says 0. And then we would turn the whole counterweight forward until we get to the tracking force we want. In the case of our Denon DL-160, we want to set that to about 1.75 grams. So we just went through balancing and adjusting the tracking force, kind of using the manual method. Another way you can do it, I like to use this method myself because it's a little more precise. I don't always trust the numbers on the dial on the back of the tone arm, is to buy this tracking force gauge. You can buy these online for typically $10 to $15 range. The idea is we're going to sit the tone arm on this little disc here, and then it turned off, which is very annoying. So we're going to have to start again. Okay. So we're going to sit the tone arm on this little disc, and then it reads out the tracking force on the display, and I think that says 1.77, so which is close enough to the setting on the dial there at 1.75. So we're good to go. We just finished setting the tracking force. Again, whether you do that using the dial only or you buy yourself a tracking force gauge, it's up to you. The very last step is something called anti-skating. And I can demonstrate that here. I'm going to push Peter's camera holding limits to the maximum a little bit. But so the idea with anti-skating is, as the record is playing, the tone arm is being pushed across the record or pulled across the record by the groove. That applies an unequal force on the walls of the groove and would cause potentially excessive wear or an imbalance in the sound. So what anti-skating does is apply an opposite force that keeps the tone arm properly tracking centered in the groove. The best way to show that is with the arm back in a balance position and the anti-skating set to 0. Let me use my little pointer here. It's set to off. You'll notice when I put the tone arm on the record, it stays wherever I put it. If I turn I'm going to be in the camera shot here for a second. If I turn the anti-skating, notice how the arm immediately moved back over. Now when I put it on the record, it comes back. That's that counter force that counteracts the centrifugal force that's pulling the cartridge across towards the center of the record. A long bunch of words to basically say whatever your tracking force is, set the anti-skating force to the same number. So for our Denon cartridge, we set the tracking force at 1.75 grams. So we're going to want to adjust our anti-skating so that it's 1.75 grams. That's all you have to do. So in previous episodes, I've fired up the device we've been playing with, the component, and let you guys listen to it. In this case, we're not going to play a record back on this. Wouldn't really serve any purpose. It's not going to sound right over the video. What I'm hoping you got from this episode is if you've got an old turntable that needs some repair or even needs a whole new tone arm, that it's really not that difficult to do. It's kind of a fun project. That's it for this episode of Not Quite Dead Hi-Fi. I think we've definitely saved this Micro Seiki DQ-3 from the grave. As with other episodes, if you need more information, be sure to visit our website, notquitedeadhifi.com, for more information. And I'll try to post some information about that little strobe box that I showed earlier in the video. My name's Jeff. Thanks for watching.